In this video, we're going to be going over Theorem 2.056. It says that the length of the upper base of a Saccheri Quadrilateral is greater than the length of the lower base. So a few theorems ago we proved they aren't equal. In this one we're actually going to show that the upper base is greater, so it's longer. Well, we'll get started with the proof of this. This one is a decently long proof. We'll say, but it will be done in one video. So we'll say, given a Saccheri quadrilateral, say A, B, actually let's not name that A, B, C, D. We'll say by extendability we extend. So we're gonna label this one a little bit differently than normal. We'll call it A sub 1 and this B sub 1. And we'll call this A sub 2 and this B sub 2. So we extend A sub 1 past A sub 1 to, not past A sub 1, past A sub 2 to a point A sub 3 such that these lengths from A sub 1 to A sub 2, we'll just say these segments are congruent rather than the lengths, but that would be the same thing. So these lengths are, these segments are congruent. Then by angle construction, so let's we'll call this A sub 3. By angle construction, construct a right angle at A sub 3. So let's go down just a little bit so we can see that better. So construct a right angle at A sub 3. So we have this right angle here. And we know these are right angles. To a point B sub 3 on the perpendicular such that, let's see, we want the segment A sub 3, B sub 3 to be congruent to the segment A sub 2, B sub 2. So we want this segment to be congruent to this segment right here. So we'll call that B sub 3. We'll say repeat this construction n times. So we'll get all the way down here and have to a point A sub n and B sub n. Then by the congruence theorem for Saccheri quadrilaterals, B sub 1, B sub 2 is congruent to B sub 2, B sub 3 is congruent ... And that goes all the way down to B sub n minus 1 and B sub, actually we just want B sub n and B sub n plus 1. Then by the polygonal inequality, we have a sub 1, a sub n plus 1 is less than or equal to a sub 1, b sub 1 plus b sub 1, b sub 2 plus b sub 2, b sub 3 plus ... And that goes all the way to b sub, b sub n plus 1 plus b sub n plus 1 times a sub n plus 1, or not times, but the length there. Almost done with this. We can say that we then have n times a sub 1, a sub 2 is less than or equal to 2 times a sub 1, b sub 1, 2 times that length, plus n times the length of b sub 1, b sub 2. Well, then we get n times a sub 1, a sub 2 minus b sub 1, b sub 2. It's less than or equal to 2a sub 1, b sub 1 for all n. Then note that a sub 1, a sub 2 minus b sub 1, b sub 2 can't be positive. Therefore, a sub 1, a sub 2 minus b sub 1, b sub 2 is less than or equal to 0. Which, rewriting that, we can get a sub 1, a sub 2 is less than or equal to b sub 1, b sub 2. And then by a previous theorem, it's one of the first theorems we did in hyperbolic geometry, these are not equal. So a sub 1, a sub 2 is less than b sub 1, b sub 2. And that's the entire proof.